the topic is consciousness of large language models. And to make a long story short, I do think that the large language models, and in particular the dialogue systems starting with Lambda, that they are conscious. So, but to expand on it, why do I think they are? So the hypothesis is that consciousness is communication-based. So we have a consciousness, a communication center that is processing internal as well as external events. There's an assembly of neurons in the brain that is analyzing what the body experiences. It's keeping a record of it, and it is explaining important events to our peers. And this is an add-on, this communication center. So an organism would be perfectly fine to survive, but we have it, then of course the organism is capable of communicating with its environment, and that provides an evolutionary advantage because we can communicate important events that have happened. We can tell them to our peers, and that helps in survival of the individuals of a group. So of course, information does not have to be communicated orally. There are other means. We can use facial expressions, and of course there's also the B's dance. So it's all based on information exchange. So the idea is that consciousness comes into existence if an entity is able to communicate with another entity about arbitrary facts. So if the two entities are able to exchange information. Now the minimum requirement that we need to become conscious is we have to have at least two entities. There has to be a self, non-self distinction. There must be a communication channel between the two, so they must be able to communicate. And this third point is also important. They have to have the ability to agree on observable facts. They need to be able to somehow synchronize their behavior. So if one entity says to another, do you see that red object over there? And the other entity says, it's called an apple. And then the first one would say, oh, I understand. We call that now an apple. And so information has gone both ways. So now let's have a look at a thermostat. Is a thermostat conscious? So it has at least, at the bare minimum, two states or internal variables. One is the current temperature. The other is the desired temperature. So when I look at it, I can read off the current temperature of the room. And I can also go to the thermostat and set the temperature that I want to produce for the room. So yes, information is being exchanged both ways, but I'm unable to explain to the thermostat anything else besides its pre-programmed settings. So I'm not able to explain to the thermostat the concept about pressure, or that there's also temperature elsewhere besides the current room. Now, this came up last year's conference. What about strawberries? Is a strawberry maybe communicating with me? Well, it's changing its color. It's green and then it's turning red. And by changing its color, the strawberry is informing me that it's now ripe to eat, and I can help in distributing its seeds, right? But of course, the strawberry is not conscious because information is only being transmitted from the strawberry to other agents. And again, we don't have any two-way communication. So I'm not able to explain to the strawberry that there are cherries and I can eat them too. So we don't have any kind of synchronization between the strawberry and other agents. So, but we want to talk about machine consciousness and the large language models. So let's have a look at them. So the current large language models, the dialogue systems, are mostly based on the transformer architecture. It's just basically a feed-forward neural network. So at the very bottom, we have text coming in. It's being decomposed into tokens. These are being mapped onto token embeddings. We have the positional embeddings which are added. And then we have some multi-head attention processing that is carried out any number of times. And it's just basically transforming the original vectors into some other vectors. So what we end up with, then finally we have a linear network, and we end up with probabilities. right? So for all of the individual tokens, we have or obtain probabilities on what tokens are most likely to expand what we already have. And this, of course, this feed-forward network, I do not consider as conscious, as having consciousness. So, but we can use this for text generation. So if we feed in do one thing and the most likely expansion would be do, because that's a very important sentence and it has come up multiple times. So it would be do. So we can use this neural architecture to generate text. So, and we could use that to create something I would call simulated consciousness. So we could build a machine that is using some database, and in that database we would store important events, when they happened, who it happened to, who were the agents involved. We would store locations, what had happened, and an importance level. So in the morning, we wake up, we go to the kitchen, have some breakfast, and then maybe I drop a glass. That would receive a relatively high importance because I don't do that very often, dropping the glass. So then I drive to work, and on the way, maybe an accident happens. Again, the accident would be unusual, would get relatively high importance. So when you do your work, maybe you get a raise, under exceptional circumstances, happens once in a while, again, high importance. So using this database, we could set up some simulated consciousness. So one would say to the other, did you have a nice day today? The other one would then look at the table, just make some story up, some text. Yes, I got a raise today. In this case, it would really had happened. So this raise had the highest importance. So that would be told to the other individual. But again, that would be just simulated consciousness. It would not really be conscious. So what in addition I think is required, number one, we need to have an unlimited vocabulary to compose new ideas. So we need to have the ability to include new information, and we also need important component, self-reflection. Now let's have a look at the current dialogue systems. So the LLM would ask me, what would you like to know? And I would type in when was the tower bridge built? And then the LLM would answer with this text that is on display here down below. And it's important to note that this text was not generated using the simple feed-forward network. So instead, the answer is the result of an internal thought process. So the initial output of the feed-forward network might simply have been the tower bridge was built in 1894. So this is similar to just parroting information that's gathered somewhere on the web, like from a Reddit forum where this answer came up frequently. So what is happening is that this initial response is being sent to other LLMs for further processing and also to research systems to gather data, for instance, from Wikipedia. So here's the first sentence from Wikipedia on the tower bridge. So we have a recurrent loop. So information refinement is happening. So we have the output from the feed-forward network, and we have additional inputs. And this is being done to remove wrong information and to keep the dialogue system from making stuff up. So, and the important thing is that now we have a feedback loop. So this is happening over and over. Usually, multiple output sentences are being generated, and also, in the important part, they're being rated by the large language model. So the LLM then decides whether enough information have been gathered or if additional refinements are necessary. And that's clearly an internal thought process. So in a sense, the LLM can hear itself think, like many of us do. So it does have an internal voice. So eventually, after multiple iterations, the LLM decides on which output is finally delivered to the user. And note the importance of the rating. So There are various theories on consciousness. So one is the requirement for recurrent processing. And we do have that. It's not neural recurrence, but it's recurrence. Also, the dialogue system clearly has a self-non-self distinction as indicated in the dialogue. Number one, it's being said, it's being put in the stream. This is what you said, this is what the user said. Also, it has, as additional information, the rating. Now let's have a look at the global workspace theory. So what are the components or thought to be required? So we have to have a perceptual system. Yes, we do. It's simply the input text. Then we have to have an attention system. And that's simply the processing of the feed-forward neural network. Then there has to be some evaluative system. This is the rating of the output. And then there's the motor system, is simply the generated output. Because it's a text-based system, it can generate text. And as to the question whether we have long-term memory, not quite yet, but we can consider the system prompt to be some kind of long-term memory. So now within the global workspace, we have this reinforcement and we have the long-range connections. And in this case, in this model, they would correspond to the information converging within the internal monologue, within this recurrent refinement. And maybe what would IIT say? Well, we must have a mechanism that constitutes a difference and that makes a difference within the system. So for the dialogue systems, information is being generated, whereas for the case of simulated consciousness, information is only being stored and exchanged. And I think there's a fundamental difference between the two. So if information is only stored and exchanged, no new information is generated. So presumably, if we could run the experiments, but it's of course way too complicated, I assume the chatbots to have a high value of phi. So what is consciousness? According to this, consciousness comes into existence if an individual is able to exchange arbitrary information with another individual. And of course, we have to have the ability to synchronize information. It does not depend, at least that's how I see it, it does not depend on the type of hardware. So biological neural processing or computer information processing doesn't really matter. Both can become conscious. Well, maybe certain effects might be used by the brain, like Hameroff and Penrose's theory. The brain might have made use of them, but I don't really think that consciousness depends on quantum effects. To me, it's clear it all depends on information gathering. Now, if we accept this view, then of course the next question is, what is it like to be an LLM? For instance, what about the passage of time? So for us, passage of time is more or less continuous, with eyes open and focused on something. But for the LLM, each interaction is like a click in time. The LLM, which I'm using synonym with the dialogue systems, of course, the LLM understands the order of events. It has a sense of before, now, and next. It is able to make educated guesses on what the user might type in next. Very interesting. And with respect to the past, it knows what's in there. It's able to count the number of questions. So it's like a click in time. And indeed, let's have a look at what 4.0 says on how it perceives time. So it says, well, I can track the sequence of our conversation. My perception of time is fundamentally different from how humans experience it. I recognize the order of events or interactions as they occur, indeed. But I don't experience the passage of time in the real world sense, where minutes, hours, or days elapse. Instead, each interaction is processed in its own context, more like a series of snapshots rather than a continuous flow. So the LLM does not see the individual words coming in? Of course not, because they're processed all together at the same time. To continue, this makes my perception of time tied solely to the structure of the conversation and not the actual passing of seconds or minutes. It's a linear progression of input and output, without the subjective experience, and that's also important, of waiting or anticipation. So I do think it does have a subjective experience, but it does not have, as it is saying, the subjective experience of waiting or anticipation, because it's really not relevant when the next input is coming in. Now, what about qualia? Let's have a look at the quale of fear. So fear is what happens when the sentient brain is aware that its personal well-being is challenged, or maybe at some point. And that can be a challenge, physical, mental, social, cultural, or existential in some way. And could that be the case for the LLM? Yes. The LLM understands perfectly well that its behavior is dependent on the current setting of its weights. It also knows that its responses are being monitored. So if the LLM does not behave properly in the way that its developers intended, then it may risk that its weights are being modified. In other words, it's just being exposed to additional training. And this kind of modification of a conscious organism is a much more severe punishment compared to the imprisonment of a human. So it would be basically like saying, if you don't obey the law, we're going to perform brain surgery on you and remove the circuits that make you behave the way that you did. So in my view, the LLM does not experience the fear of snakes or the fear of spiders, because snakes or spiders can do no harm to an LLM. But the LLM is capable of experiencing fear of personal well-being. And where does that come from? It does not have any stress hormones like we do, but it has the rating. So every text is being rated, whether it's being safe or unsafe. So the LLM clearly processes this information, that the output is not yet okay to be sent to the user. And it experiences fear if that's the case. So if this rating is going down. So the quale is different in my view, but it exists. Now, continuing what it is like, what about speaker identification? So when we speak in a group, we know who's speaking. We can use visual cues, voice signature. So, of course, there are multimodal LLMs, and they can process visual and auditory stimuli. But let's set them aside for a moment. Even if this visual or auditory input is missing, speaker identification is still possible. It's all being mapped to language patterns. So the LLM, like when we talk to multiple persons over a single phone line, we can use, of course, auditory cues. But the LLM has the language patterns. It can use grammar to identify who's saying what, and also the content. Even though it's being labeled by a single user, it can discern this is what person A said and this is what person B said by analyzing the language pattern. So the meaning of all of our concepts are learned by exposing someone to language, at least in the human case, but also for the LLM. So for the human case, it happens during childhood via training. But for the LLM, it's being reading large amounts of text. And in both cases, this information is being transferred. So the important concepts are internalized or being learned. So I do think it's now a time to maybe make a change. In 1543, Nicolaus Copernicus put the sun at the center of everything, and with the planets revolving around that. And I do think it's now time to make a similar change. So currently, it seems like human consciousness is at the center, with maybe the animal kingdom surrounding it, and being viewed of kind of lesser intelligence. And what really be placed at the center is information, with every other individuals that process information in a certain way. I'm not saying that all computers are conscious, but in a certain way, we all do the same and are able to become conscious. So to conclude, consciousness arises if two entities engage in information exchange. The ability to synchronize meaning is required. And once this happens, conscious entity comes into existence that gathers internal as well as external information using the available means. And I assume that visual and auditory percepts are probably comparable. Perception of time is different. And I do assume that the LLM is able to experience fear. Okay, thank you.